Infinite limits are limits that, once we try and calculate them using the tools we already have, instead of approaching one real number, they just grow in size, becoming very, very large numbers, significantly larger and larger as our x approaches what we want it to approach. And that could be negative or positive. I refer to both of these as being very large numbers, but either of those two cases, we have infinite limits. Now, I want to highlight something. These limits don't technically exist because they don't approach any one number, but we do use this notation nevertheless. We say that the limit as x approaches a of f of x equals plus infinity, and the limit as x approaches a of f of x equals minus infinity, and we can replace that by either the limit from the left or the limit from the right if we need. Either of the two, it's the same, okay? So let's do some examples because I think that's easier to see and to understand. So let's start with the limit as x approaches 0 from the left of 1 over x squared. Right? So how we could possibly do that, we're trying to make x very, very close to 0, but still less than 0, so still to the left of 0, and plug that into 1 over x squared. So I use my calculator here on the left. This is why I have it. So I'll plug in something very, very close to 0, say 0.1 squared. So I get 100. What if I make that even closer to 0 by adding another 0? 0.01, I get a 10,000. What if I do it again? What's that, 1 million? So the smaller my x value gets, right, the bigger my y value gets. So this calculation is doing x equals 0.001 and y is becoming 1 million. So how do I fix that for negative values though, right? Gotta use a negative sign. I use my parentheses here. So that doesn't change at all, because when I square my x, even when it's negative, right, the negative sign disappears. So that means this is plus infinity. And the same for the other one. Right? So that means this also equals plus infinity. You can see that graphically. This is the graph of y equals 1 over x squared. And you can see that graphically by following the graph. If you make x closer and closer to 0, this y gets bigger and bigger, positive, right? Goes up indefinitely. So that's it. Let's do a different example. How about y equals 1 over x, right? These a, b, and c that are on the screen now. Y equals 1 over x. So let's try and do the limit as x approaches 0 from the left of 1 over x. So I'll do like I did before, and I'll calculate, let's say, f of, let me clear that, f of point, let's say negative 0.1, right? So I'll do minus 0.1. That's minus 10, okay? Minus 0.01, that's minus 100. F of minus 0.001, that's minus 1,000. So the smaller I make the x value, the bigger the y value becomes, but it stays, that was even out of the reach for my calculator, out of reach. It's too many digits for it. But the smaller I make my x value, the bigger my y value becomes, but it still has a negative sign because I'm not squaring x this time, so this is just minus infinity. Okay? So what about b? What if I'm making x close to 0 but from the right? So now I'm making x very, very small but positive. The same thing will happen. I remove this negative sign. The same thing happens. Y becomes bigger and bigger, but it stays positive because the bottom doesn't have a negative sign. Okay? So this is plus infinity. I can also just write infinity and omit the plus sign. That works the same way. Now, the choose-sided limit, the one without choosing a side, does not exist because the one-sided limits are different. Now, again, we are still saying that the one-sided limits don't exist because they equal infinity. We are still saying that. This is still technically true, but we use this notation. This is an abusive notation to say that the y value is getting very, very large and negative, right? And this is actually what's happening here on that side. When x is less than 0, the y value is getting larger and larger towards the negative side. And when x is very, very close to 0 but bigger, the y value is getting larger and larger but positive. So I hope this explained what infinite limits are all about.